Hello everybody, let's keep learning S-domain analysis module for continuous systems. Hello students, we learn 4.7 below, S-domain analysis and application of the system. First of all, let's look at the S-domain analysis of the system. First, look at how to evolve from the time domain equation to the S-domain equation. First, look at the number multiplier according to linear characteristics. The number of time domains multiplied to the S-domain is also the number multiplier. That is, Fs becomes AFS. Then look at the adder. Based on the linear properties of the Laplace transformation, if F1t, F2t acts on the sum system, its response is F1t plus S2t. F1s, F2s acts as an incentive on the sum system. Response is F1s plus F2s. Look at the integrator again. Excitation signal Ft acts on the integrator. The response is the integral of Ft. According to the integral property of Laplace transformation, Laplace transformation of Ft integrals equals to integral of Fs over S plus F0 negative over S. So in the S-domain space, the Laplace conversion of Fs integrals is equal to Fs over S plus F0 negative I's integrals over S. The sum of the two parts can be represented by sigma in sum sign. Integral symbols can be replaced by 1 over S, so the integrator becomes Fs. There is 1 over S in front, sum sign behind. Then Fs is equal to Fs over S. Add the integral value of F0 minus. Let's look at the integrator in the zero state. In a zero state, when the F0 minus integral is equal to 0, at this point, Ft as the integral becomes the Fs over S. That is, the Laplace transformation of the integral Ft in S-domain space is equal to Fs over S. Example 1. System block diagram as shown in Figure 1. Known Ft equals epsilon t. 1. Use frame picture of S-domain at zero state response. 2. Punch response and a zero state response. Let's look at the block diagram of time domain. So how to change a time domain's block diagram to an S-domain's block diagram? The first step is to turn Ft into Fs. Yt becomes Ys. Xt becomes Xs. The second step is because it is a zero-state response, then the S-domain's integral is Fs over S. So you can turn the points number into one of the S. Step 3. Keep the sum sign sigma. The number of multiplier unchanged. This turns the time domain block diagram into an S-filled block. Below solve the impulse response. The equation for S-domain can be written according to the S-domain block diagram. Right end of sigma, we can get this kind of formula. Ys is equal to, then according to the left end adder, we can get Fs is equal to. Divide Ys by Fs below. That is, the right end gets Hs on the upper left end. So Hs is equal to 3 plus S ratio, S squared plus 3S plus 2. And then partially unfolded is equal to 2 over S plus 1 minus 1 over S plus 2. Here is an impulse response. Turn Hs into reverse transformation. 2 compared to the previous S plus 1, reverse transformation is 2 times e to the power of negative t. 1 over s plus 2 reverse transformation is e to the power of 2t. Inverted transformation of hs is that ht is equal to 2 times e to the power of negative t, subtract e to the power of negative 2t. The impulse response is obtained. Following, we solve zero-state response. So how to solve the zero-state response? According to ys equals hs multiplied fs, we know that ft is equal to epsilon t. Then its Laplace transformation is 1 over s. So ys is equal to hs multiplied by fs. We've solved hs. Fs equals 1 over s. Fs equals 1 over s. Then there is ys and then a partial split unfold. You can finally get yt. Yt is equal to plus or minus 2t side of the second half e. The multiplication of the epsilon t. Let's look at example 2. If the initial state of the system in the above example is y 0 minus equals 1, y 0 minus equals 2, solve zero input response of the system. Above, we get the value of hs. It's equal to s plus 3, then the square plus 3s plus 2. According to hs, we can write differential equation C0 for zero input response. Then the zero input response differential equation is yt plus 3 times yt plus 2 times yt equal to 0. Laplace transformation with initial value on this zero input equation. The Laplace transformation is the next. And finally, you get ys. Part split expansion of ys, that is equal to 4 compared to s plus 1 minus 3 compared to s plus 2. 4 compared to the previous s plus 1, reverse transformation is 4 times the e to the power of negative t. 3 compared to the previous s plus 2, reverse transformation is 3 times the e to the power of negative 2t. Finally, we get a zero input response. Its value is yt equals 4 times e to the power of negative t. Subtract 3 times e to the power of negative 2t. Let's look at 2. Magnetic field occurrence control system based on S-domain analysis. Magnetic therapy. The magnetic field acts on the human body. A way to treat a disease. Magnetic fields pass the movement of microcharged particles that affected the body. Electric field, distribution cell membrane permeability, and the magnetic moment orientation of biopolymers, etc. So that the biochemical physiological processes of tissue cells change, produces swelling, analgesic, and promotes lymphatic and blood circulation. Switch timing control through the system circuit. Switch timing control through the system circuit. Switch timing control through the system circuit. Cause it generate a pulsed magnetic field through the coil. During RLC decay oscillation, recycling power from capacitive reverse charging enable the circuit to generate a bipolar pulse current. The RLT circuit pulsed magnetic field generator is a storage capacitor. Instant discharge in the RLC circuit produces a pulsed current through the coil, creating a pulsed magnetic field. The diagram is the system block diagram of the pulsed magnetic field generator of the RLC circuit. Attenuation oscillation process through the RLC second-order circuit. Reusability of electrical energy released after a power outrage on the coil. It can also produce a pulsed magnetic field, and in the energy-efficient magnetic field generator, the role of the RLC second-order circuit zero input response can be divided into energy saving, and the refuse process, and energy saving post-magnetic field generation process. When the switch is off, capacitor C will be discharged by resisting R coil L until the initial energy of the coil is exhausted by the resistor. In the reference direction of a given voltage current, according to Kirchhoff's law, there is URT plus ULT plus UCT equals 0. Then the UL at both ends of the UR inductor of the resistor, generation 1 will get 4. 4, the equation is the secondary equation. We solve this parallel equation and we get its signature root. Depending on the circuit, it is known that UC 0 minus is equal to US, IL 0 minus equals 0. So because the circuit is in a zero input state, so UC 0 negative is equal to U plus 0 negative equal to US. UL 0 negative equals UL 0 positive equals state 0. Then we can get UC 0 plus out of the, and then the two ends of the equation are transformed into Laplaces. You will get UCS. Then use LAT, LAB to partially unfold the op tab. A Laplace transformation solution program as follows. Then you can get the following two curves. Wave surface changes for capacitive voltage UC and coil current IL. For example, as shown in these two curves, from this diagram we can see whether it's capacitor voltage or coil current. Sign functions are attenuated. Change the symbol periodically during the transition, so the coil discharge is oscillating. During decay oscillation, coils and capacitors exchange some energy periodically. Resistance is consuming energy all the time. This process principle can be used for pulsed magnetic field generators, can also be used for reuse when the magnetic field generator is powered off. When the magnetic field generator is powered off and stored in capacitors in the form of energy, in order to achieve the goal of energy-saving reuse. Okay, that's all. Thank you. Class is over. Thank you for listening.